We'll be starting with the calculus portion. In order to start with calculus, I'll start from class 11. You first need to know class 11 basics. For that, first, I'll need a certain knowledge of straight line geometry. First, we'll revise that. When we talk about line, I'm not expecting you to know anything. I'll teach. When we talk about straight line, in order to draw the graph of a line, we need 2 points, right? Whenever we need to draw the graph of a straight line, we need 2 points. So supposing I have this line. Every line that we draw, no matter how it is, it will always cut the x-axis at some angle. Agree? At some angle, it is definitely going to cut, or it will be parallel to the x-axis. One of it will definitely. Now in maths, there is a rule. You always measure the angle with the positive side of x-axis. This is your baseline. This is the baseline. And the angles will always be measured in the anti-clockwise direction. In the anti-clockwise direction. That is why whenever in the Cartesian plane also we are naming the quadrant, we name as first, second, third, and fourth in the anti-clockwise order. So everything in maths is done in an anti-clockwise order. Okay? Now this line makes an angle here with the positive side of x-axis in the anti-clockwise direction. This is known as angle of inclination. So every line will have some angle. Okay, we are only bothered with the x-axis angle. If it is sorry, if it is parallel to x-axis, it will make 0 degree. If it is perpendicular, it will make 90 degree. Okay, so no matter how the line is, it will always form an angle. Okay, now with the straight line, if you have remember class 11 chapter, in straight line, the first and foremost thing that we talk about is slope or gradient of a line. Now, slope or gradient is a unique ratio associated with each line. Associated with each line. And this ratio can be obtained in two ways. One, with the help of trigo. We won't need that much. So if I have this line and it makes an angle theta, then slope, which is denoted by small m, in that case, our slope will be tan theta. Slope will be tan theta. So tan 0, 0, tan 30, 1 by root 3, tan 45, 1, tan 60, root 3, tan 90, undefined. Clear? Clear? And using points. This is what we'll be needing. So if I want to draw the graph of a line, how many points do I need? So this is the line. One point is x1, y1. The second point is x2, y2. If I talk about the derivation of this part.
मैम एक डाउट है मैम
बोलिए
मैम अभी इसका
सॉरी
वो जो आप एंगल ऑफ इंक्लिनेशन बताया ना मैम मतलब वो क्या समझ में नहीं आया उसका concept का
every line will always have an angle that is forming with the positive side of x-axis and will rotate in the anti-clockwise direction. You could have taken this angle also, this also, this also, but no. When we talk about angle, we're only talking about the angle that it makes with the positive side of x-axis. That means this side, and it has to be measured in this.
Okay, understood, ma'am.
That is always the thing.
समझा.
So now, if I have this line, so on this line, I have 2 points, x1, y1. So this length is x1 and this perpendicular length is y1. That is what the coordinate means. Yes or no? Now this point is x2, y2. So from here, this is x2. This part is y2. If I draw a perpendicular here, this length will be x2 minus x1. So this length will also be x2 minus x1. Now, if this is y1, this will also be y1. So this part will be y2 minus y1. Online, is it okay till here? Now, now, if this is theta, angle of inclination. So now, if you notice, parallel, parallel, transversal. This angle will be equal to this angle, corresponding angle. Hana, online, yes or no?
हाँ
So
मैम.
this angle will also be theta. Huh? So if I talk about this triangle here, this is theta, this is x2 minus x1, this is y2 minus y1. So tan theta, tan was perpendicular by base, y2 minus y1 by x2 minus x1. Tan theta was itself the slope. So slope of a line M will be y2 minus y1 by x2 minus x1. So if I have to find out the slope of a line, one is if I know the angle theta, slope will be tan theta. And if 2 points are given on a line x1, y1, x2, y2, then slope M will be y2 minus y1 by x2 minus x1. Change in y by change in x. Delta y by delta x. Delta means change. So you can take any point to be x1, y1, any point to be x2, y2, it doesn't matter. For example, if I have a line 1 comma minus 2, 5 comma 6, you can take anyone to be x1, y1, it doesn't matter. Suppose I take this to be x1, y1 and this is x2, y2. So m will be 6 minus or minus 2 upon 5 minus. Basically, subtract the y in the same order, subtract the x also. If I have subtracted y in this order, I'll subtract x also in this order. Or if you want to do the other way around, subtract y in this order, then subtract x also in the same order, anyway. But y will be in the numerator, x will be in the denominator. 8 by 4, that is true. Slope of the line will be 2. So this is what we need. So if I want to find out the slope of a line can be obtained by y2 minus y1 by x2 minus x1. Online, is it clear?
हाँ मैम.
Yes. We don't use tangent. Very rare case, just for some assertion reasoning or something in case you need it, that's why I wrote it down. Otherwise, we do. We'll only use the coordinate format. Any doubts till now? Okay. Now we'll again go back to this topic once we do tangent, normal, and those parts. But for now, this is okay for me. Yes. Now, when I talk about a function, fx, say x square plus 1. So if I put x equal to 2, that means f of 2, 2 square plus 1, that is 5. Agree? So this will be represented by the point 2 comma 5. If I have to plot it on the graph, I'll plot 2 comma 5. 2 is the input, 5 is the output. If I take x equal to 3, f of 3, 9, 10. So I'll be plotting 3 comma 10. So what am I plotting is, I'm plotting x and its functional value fx. Yes or no? Here also 3 was x, 10 was f of x. That means when we plot, we use, if the x coordinate is a, y coordinate will be f of x. The value that you put in the get from the function after putting the x coordinate a. Agree? So if I'm plotting the point here, this point is a comma f of a. That means this length is a and the height is f of a. Do you all agree? Clear? Yes, Varun?
तो इसका मतलब y is always dependent on x.
Yes. In case if it suppose y equal to x square. So only if you put x, you'll get y. There will also be certain equations later on where x will be in terms of y.
Then ma'am, x is independent then.
Huh. X is independent, y is dependent.
समझ गया. Thank you.
So in this case, Y and fx are same. Y and fx means the same thing. Whether you write y or you write fx, it is same thing. Clear? So this is the part that I need from straight line. What did I say? In order to find out the slope of a line, I need 2 points. So how do we find slope of a line? M is equal to y2 minus y1 upon x2 minus x1. When we plot any number, any point on the graph, we use the coordinates a comma fa, x comma fa. The y coordinate is basically fa. Here, here, what we are starting is calculus. So actually the intro should have been given in 11. We'll start from the very same intro. Now, if you remember class 11, before doing calculus portion, you were taught sets, relation, function. Only then you were taught calculus. And even before calculus, you were taught limit. So sets, relation, function, limit, then comes calculus. And that is not just a coincidence, it's a necessary order. Why is that so? Let first of all define collection, certain groups which have similar characteristics. So group A, group set 1, set A, then set B, group 2, collection 3, group C, set C, and several more. Then when we talk about relation, what they do is they form a connection between an element of set A is being paired up with an element of the set C. 1 is related to 3. So we form a pair 1, 3 and plot it in the graph. 2 is related to a number 5. So we take the coordinate 2, 5 and plot it on the graph. Function is just the equation format of those pairs. So when I talk about equation fx equal to x square, we get infinite number of points. If I take 1, I'll get 1, 1 comma 1. If I put 2, I get 4, 2 comma 4 will be the point. X square is the equation. If I put 3, I'll get 9. So 3 comma 9 is the point. So 1, 1, 2, 4, 3, 9, 4, 16, 5, 25. For example, I've taken 10 points. Okay. And put it on the graph. So you join those 10 points and you get one shape of a graph. Fine, you have drawn the graph. Now what happens is, certain times what happens is, if I talk about the sales report of a company, I've taken 20 years. So they have given you 20 quarterly reports. 20 into 4, 80 quarterly reports. And just by looking at it, it's very difficult for me to ascertain what is going on in that report. But instead of that, if you give me the sales graph of that, what I can see is, in this particular year, they reached the maximum for some time. Then what happened is some drastic thing happened and they went to a drop. At point A, whatever year that is, they reached a certain maximum value. Then they suddenly made a fall for some reason, whether it was a faulty manufacturing portion or whatever may be the reason, bad marketing or some legal case going on, their sales went down. But they picked up after B and reached their maximum at C. But again, they reached their minimum, very huge minimum at D. The amount got again picked up and reached the point E. And then whatever happened. So by looking at it directly, I can pinpoint at the year A, C, you and E, you did something good. Right? Whatever you did from the point B to C, repeat that because that was a good thing. Whatever you did after C, that was a bad thing. Do not do it again. Do not try that again. These things can automatically be known once I know this graph. Again. So there are certain things that can be very easily understood from the graphical point of view. But if you would have given me the same thing in a chart or in a table, it would not have been possible so easily for me to ascertain it from. So there are certain things which are very easily understandable using a graph. But there is a problem. We don't know how to draw graphs. Never in our life, in our academic period, have ever been taught how to draw. Even if you do your graduation also, you will never be taught. So how do we understand certain graphical properties? What graphical property? Where did you reach your maximum? C. Where did you reach your minimum? D. Where you were going in a growth stage from B to C, B to E. Where you were going on a decaying stage, A to B, C to D. Agree? So when the function was increasing, when were you doing good? When were you doing bad? When did you reach your maximum? When did you reach your minimum? Where did your function take a turn for bad? All these things can be easily understood from the graph, but not from the table. And there are many more things that we find out from the graph. But if you're not even good with the graph, for example, even if I learn, for example, x square, I'll learn the graph of that. You tell me x cube, I'll also learn the graph of that. But now you'll just get up one day and say x cube plus x plus log x plus 2. I can't draw the graph of that. It's impossible for me, right? So certain specific figures or famous figures, we can still learn the graph. But for every graph, every equation you tell me and ask me to draw the graph, I can't. Because like I've told you, x square plus 1. I may take 10 points. I've drawn them. But how do I know that after the 10th point it is not taking a turn or it is not increasing again? How do I know? No, I can't because I've only taken 10 points. So graph is not possible for us. But we have to study the graphical properties. We can't be unaware of something. We can't be ignorant of certain facts. So how do we understand or how do we learn those properties? This is where calculus comes. Calculus tells you that you are not good at one thing, which is drawing the. That's okay. But you're good at one thing, which is algebra. So calculus helps us to understand the graphical properties of a function with the help of algebra. So by using relations, by using function, by addition, subtraction, multiplication, it helps us to understand the calculus portion, algebraic. Using algebra, it will help us to understand the graphical properties of a function without ever actually drawing the. And that is the job of algebra. That is the job of calculus. Now, straight from algebra to calculus, we cannot jump. So, limit forms a bridge between them. Limit helps us to understand how to make the transformation from algebra to the calculus portion. That's why in 11 there was a huge limit portion, limits and continuity. Right? Now, what does limit say? Limit says that if your function, when I talk about function, you are talking about two numbers, x, which is your input, y or fx, which is your output. So if I say that x tends to 2, the value of x is going near 2. Near 2 can be 1.5, 1.6, 1.7, 1.8, 1.92, or 2.5, 2.4, 2.3, 2.2, 2.1, then 2. You are approaching 2. It can be from the left side or from the right hand side. If from both the sides you reach the same answer, for example, 5, that means the output is sitting at 5. But from the left side, you reach 4. And from the right hand side, the function leads you to 7. That means you are at two different locations. So the function, the limit does not exist for that. You're sitting at two different locations, the limit does not exist. Agree? So when we talk about limit, we write limit x tends to 2 fx. When x is going to the value 2, can you tell me the y coordinate, the value of fx, what it should be? If I write 5, that means if x goes to 2 from whichever angle, then the value of the function will be 5. Agree? And if I say does not exist, that means you cannot trust such a function, you cannot study such a function. And if I can't find limit, I cannot study that. Here, here. Huh? So what does calculus help say? Calculus helps us to understand graphical properties of a function with the help of algebra without actually drawing the graph of the function. Clear? Now, when we talk about calculus, there are three things: continuity, differentiation, or derivative. Third is integration. Continuity was completely limit, 11. You don't need it. What did continuity tell us? That if I'm drawing a function, it breaks down and it goes up. Sale of Domo 650 in the year COVID year. We were projecting the sale to be somewhere here in the year 2020. But because of COVID, the sales suddenly shoot, right? The sale suddenly went up. And in the year 2020, the actual sale went up. And then it again got normal. Agreed? So such a rapid increase or decrease makes the function discontinuous. That means something historic or something unforgettable has happened at that particular moment, for good or for worse. So study that separately. Agree? So continuity told us that if the graph of a function breaks down at some point on, if yes, then this is the point that we are talking. Differentiation or derivative. This is basically related with the slope, which I'm treating. He was teaching you right now because this is what I'll be starting. Slope helps us to find out the rate of change. Why is that so? Your slope is y2 minus y1 by x2 minus x1. Change in y with respect to change in x. So change of distance with respect to change of time. That was speed. Speed is rate, right? So change in y by change in x gives you rate of change of y with respect to x. So slope basically gives you rate of change. So derivative basically gives you rate. Then we have increasing, decreasing. As I said, when is a function going for good? When is a function making a fall? Where is your maximum or minimum value? All these things are the applications of derivative. That's why in commerce section or any economic student, differentiation plays a vital role. You cannot study economics without, you cannot study any change, diagrammatic change without calculus. Right? And EOD, application of differentiation or application of derivative, is your lengthiest chapter in this course because it has tremendous application. And third is integration. Differentiation started in 11, it will get ended in 12. Integration starts in 12. There was no portion that we learned of integration in the 11. In integration, we talk about what differentiation gave. So differentiation gives you the answer. Integration in return gives you the question. If differentiation is telling you the rate is this, integration will tell you what was the original value you were talking about. Right? So integration basically step back, retraces the path back to the original. Clear? This is the layout of our entire. Yes, sir.
मैम आप इकोनॉमिक्स बोल रहे हैं ना मैम?
हाँ.
तो इकोनॉमिक्स मतलब जब डिमांड ऐसा डिमांड और प्राइस ही रख सकते हैं मैम. सपोज डिमांड ऑफ टोमेटोज बढ़ रहा है तो प्राइस.
Any economic law you talk about, whether you the basic law of demand and supply comes from it. You talk about marginal cost, marginal revenue, your equilibrium point,
हाँ
everything
मैम,
comes from differentiation.
समझ
If the slope is going upward, why does the rate increases? Why does the cost increases? All these things, differentiation is what teaches. We'll go to those things. We'll study that application.
अंडरस्टूड.
Clear, clear? Note down. Okay. So now we'll start with differentiation or derivative. So now what happens? Supposingly this is my curve and I want to study the property of the point A. So right now I've drawn a parabola, but every time you don't have a parabola, you don't have a U-shaped curve. Your curve may look like any way. It may be zigzag, it may be spiral, it may go up and down, haphazardly, it may be anything. So how do I study the properties of a function at one particular point? So we're not good with curves, but we're good with one shape, which is straight line. If we know anything about a curve, about a shape, it is straight line that we are most familiar with. No doubt our knowledge in that also is very minimal. But in comparison to rest of the shape, straight line is something that we are most comfortable with. So what I will do is, I will study the property of this particular curve at the point A with the help of a straight. If I'm able to do that, then I'll say that the function is differentiable at the point A. But if I can't study the property of the function A, function at the point A, then I'll say that since I'm not able to use a straight line for this, I cannot differentiate this function. The function is not differentiable. So differentiable indirectly says that can you use a straight line to understand what is going on at the point A? If yes, it will be differentiable. If no, it won't be differentiable. So what type of a line can I use? Supposingly, I take this line. Point A and B, and line is L1. So this line L1 will have how many slopes? One. Whether you use a point or use the trigger, the slope can only be one. Each line has only one slope, exactly one slope. So if every property of a straight line comes from slope, whatever it may, you don't know it maybe, but every property of the straight line comes from slope. Okay. So if this line L has only one slope, that means every single property that I find from here, angle, increasing, decreasing, whatever I find, will always be one value. So that value will be given to point A as well as to point B. That means point A and point B will share same properties. Yes or no? According to this particular line. But graphically, if you notice, point B is in a very initial stage, very low stage, and point A is almost at the maximum value. Can B and A exhibit the same property? Graphically, can you see it from the graph? Can B and A give you the same property? No. That means, can I take this line? Definitely no. Because this line is telling me that B and A exhibit same property, which I can see is completely wrong. That means I cannot take such a line. What kind of a line? A line which cuts my curve at 2 points. Because even if I take some other line, it will cut the curve at some other point, this point, B. Again, it will say that A and B have the same property, but no two point in a line curve can have same property. Can we ever have the identical result in 2 years? No, impossible. There will be some difference or the other. Similarly, any 2 point on a straight line, rarest case, except for that, cannot have identical property. That means I cannot take such a line to study the property which is cutting the curve at 2 points. That means I cannot take such a line. So how should my line be? A subline in a line which cuts my curve at exactly the point that you want to study, which is known as
Tangent.
tangent. A line that touches the curve at only one point is known as. So if you want to
Tangent.
study the point A, you can only use the tangent that we draw at the point A. Because if I take any other line, if it is not a tangent, it will cut the curve at more than one point. If it cuts the curve at more than one point, it will have 2 points having same characteristic, which is completely. So I can only take the help of tangent. Here till there. Now, if I have this curve, modulus curve, this is the shape of mod. I want to study pointing. Is this a tangent? Yes. So L1 is intersecting the curve at only 1.8. So this is the tangent. So I can use L1 to study the property of the pointing. And L2, is this a tangent? Again, it cuts the curve at only 1 point. I can see, forget everything else. This is making an angle 0 degree. It will make an obtuse angle 120, 130 degree kind of a thing. Can they have same slope? One is tan 0, 0, one is tan obtuse angle. So they have two different slopes. How can they have the same property? If L1 and L2 have different property, so you are telling me that because of L1, A will exhibit some property, and because of L2, A is going to exhibit different properties. That means the same point A, can it have two different properties? Can it ever be that I'm saying that for a year, last year I had an amazing result, and someone says that I had a pathetic result? Can it ever be? No, results are same. No matter whoever is saying point of view, good or not as good. But it cannot be to extreme situation. Your values cannot change. If I'm saying average is that is my average is that. Someone else tells you different average, that person is wrong. So here, if line 1 says that point A exhibits so and so property, line 2 says no, the point is exhibits some other property. Can it be true? No. That means taking a tangent alone is not sufficient. You should have a tangent which is unique. You can only study the point with a straight line if you can draw a unique tangent at that point. In this particular case at point A, can I draw only one tangent? No. I can draw a lot of tangents, more than one. That means point A cannot be studied by a line. Point A is not differentiable because at this point I am able to draw more than one tangent. Clear? So a function being differentiable at A means I can draw a unique tangent at the point. And that unique tangent will give me the properties of the point. Right? So if I say that a function is differentiable at the point B, what do I mean from that? At the point B, I can draw a unique tangent to the curve. If a function is not differentiable at C, so either I'm not able to draw the tangent or I'm able to draw more than one tangent. One of the two. Clear? So if a function is differentiable at the point D, what do I mean? We can draw a unique tangent at the point D to this curve. Clear? Clear? And that tangent will be used to understand the graphical properties at the point A. Clear? Online, is it clear till here?
Yes, ma'am.
Yes, ma'am.
A function f is said to be differentiable at a point A. Here, a unique tangent can be drawn to the curve at point A. Any doubts? Any doubts? No. Let us define, let us derive the
Can you
formula.
scroll up, ma'am? एक second.
I'll send you the video to write, don't worry.
मैम यूनिक टेंजेंट का मतलब मीनिंग क्या है, मतलब वो
एक
एग्जैक्टली
ही, सिर्फ एक, ना कम ना ज्यादा,
खाली एक ही बना सकता हूँ, मतलब एक ही
सिर्फ
लाइन?
एक। अगर एक से ज्यादा बना पा रहे हो तो भी डिफरेंशिएबल नहीं है, एक से कम बना पा रहे हो तो भी डिफरेंशिएबल नहीं
समझ गया।
है। क्या
Okay,
हुआ?
ma'am.
Supposingly, I'm taking this curve and I want to study the point D. I can see that a tangent can be drawn. I have drawn this curve so that you understand. The curve can look like anything. The shape can be of any sort. Okay. So the coordinate of A is x coordinate is A. This curve is y equal to fx. If the x coordinate is A, y will be the code. What will be the y coordinate? F of x, which is this line. I am here. I'm taking a point B, which is on the left side of it. That means the x coordinate of the point B will be less than the x coordinate of the point A. So if I take this difference to be h, this will be, agreed? What is the coordinate of B? What will be the coordinate of the point B, guys?
B comma f function of B.
I can't hear the coordinate, guys. I'll need a repetition. Coordinate of the point B.
मैम B comma function of B, मैम.
Wrong. I've given you the x coordinate of B, no?
Of h minus a.
Exactly.
Okay, understood.
A minus h comma f of A minus h. Agree? So if I join the point A and B, I'll get a line higher where the coordinates are already known. So if I want to find the slope of line AB, formula y2 minus y1 by x2 minus x1, y2. I can take anyone to be y2, right? Minus y1. Clear? Online clear?
Yes, ma'am.
F of A minus h minus f of A upon minus h. This is the slope of the line AB. Clear? Clear? Now you see, the gap between A and B is determined by h. If I start reducing this gap, that means I'm making the value of h smaller. So reduce the value of h, B comes here. Higher. I again reduce the value of B, it comes here. I again reduce the point h, B comes here. If I make the value of h almost h approaches 0, h tends to 0, h is almost 0. That means B somewhere here. Yes or no? And now if I join A and B, how does the line look like? The line AB looks like tangent AB. That means if I make this difference H almost 0, line AB becomes tangent AB. Online, yes or no?
Yes, ma'am.
Yes, ma'am.
So this was the slope of line AB. This will now become the slope of tangent AB under the condition H is almost 0. Yes or no? So limit H tends to 0. If you limit the value of H to be almost 0, then this value will be the value for slope of tangent AB. Understood? Understood. That means at the point A, I'm able to find what tangent. If this limit does not exist, that means tangent does not exist. If tangent does not exist, the point is not differentiable. If it exists, then the point has one tangent. Now what I'll check is, can I draw one more tangent? If I can, then it won't be differentiable because I'm able to draw more than one tangent. And if I can't draw any more tangents, so this is the only tangent possible, unique, so it will be differentiable. Yes or no? Understood the idea? So what I do is, I'm taking a point C here, same distance H. So this coordinate of C will be A plus H, higher than A, F of A plus. Clear? And if I join the point C and C, I get a line. Slope of AC. F of A plus H minus F of A by A plus H minus X, Y2 minus Y1 by X2 minus X minus F of A by H. Here. Now again, I'll keep on reducing the value of H. C will go on coming to nearer value. Yes or no? So if I make the value of H almost 0, in that case, C will somewhere be here, and I draw this. So again, the line AC will become. So if H is tends to 0, then line AC becomes tangent C. And this will be the slope of tangent AC under the condition H is almost 0. So limit H tends to 0, F of A plus H and F of A by H is slope of tangent. Yes or no? Clear? Clear? Agree? Now, if I get two different slopes, suppose the left one, AB slope is 2. It is at some angle. Suppose the slope of AB is 0. So it is 0 degree. And if I get the slope of AC to be 1, can it be the same level? It will be a little slanting in whatever order. That means if I'm getting the limit value to be two different values, that means there are two different tangents. That means point A is not differentiable. And if I get the value, same value from both of them, they are basically the same line. Slope is 0, 0. That means if we are talking about the same line, I'm just written the name here AB and here is. The line is BAC. But if I get two different tangents, 2 and 3, there are two different inclination, two different lines, two different slope, no unique tangent, two different tangents. That means the point is not differentiable. Yes? So this is known as LHT. Left-hand derivative. Derivative is another word for slope. So left side slope. Left-hand derivative. And this was RHT. Right-hand derivative. Yes. If LHT is not equal to RHT. There are two different values. Then, and what will I conclude online?
Ma'am, it's not differentiable.
Ma'am, not differentiable.
F is not differentiable. at the point A, or x equal to x coordinate was A. And if LHT is equal to RHT, for example, the value is P. For example, it is P. Then F is differentiable at A or at x equal to A. Now, how do I write? The function was denoted by fx. So the value will be written as f dash. Dash means I've differentiated the value. I have f dash. I've already found the slope of f. We usually write what x at x equal to A or f dash A. Now I've differentiated the function fx. That's why dash at the point x equal to A. And the answer that I have got is P. Agree? Agree? Dash means I've differentiated the value of derivative. Because if I only write f of A, this is the y coordinate. So I'm not needing the y coordinate. I'm talking about the derivative value of f at A. Okay. Now what was this P? This P was basically the slope of AB and AC. What was AB and AC? Tangent. So the answer that I get after differentiation is nothing but the slope of that unique tangent. So derivative, the answer of derivative gives you the slope of the unique tangent. That's why you have one application, tangent and normal. Tangent and normal. Normal will come later. Tangent. Why? Because derivative gives you the slope of tangent. That's why we have entire application in tangent. Yes? Or we also denote fx by what? Y. So you could have written y dash or y1 or d by dx. This d by dx is the symbol of differentiation. That means whatever you have written after this is your function that you are differentiating. So I'm differentiating y, so d by dx of y or dy by dx. The answer is B. ddx is just a symbol. What am I differentiating? Y, so y comes up. Here also I could have written ddx of fx is P. Is P. Why have I written x denominator? Because the everything was calculated using x as the variable. Y equal to x square. The graph is what? I'm drawing the graph of y with respect to x. That's why dx. If I'm drawing the graph of x with respect to y, I'll write dy. So dx means treat x as the variable. Du means treat u as the variable. Everything is same. Just treat whichever variable is same. Clear? So ddx is the symbol of differentiation. Whatever is written after that is what you have to differentiate, is what you have to treat as a function. Clear? So when we get the value of the derivative to be 3, what is that 3? Slope of the tangent. Slope of that unique tangent is 3. Or you can say that rate of change of y with respect to x is 3. Because slope is y2 minus y1 by x2 minus x1. Change in y by change in x, that is rate of change. So rate of change is 3. That's why we have one more application, rate of change. Clear? Yes, no. Everyone clear? No. So this is the basic foundation of your differentiation motion. Online, is it understood?
Yes, ma'am.
Um,
Yes, ma'am.
Now, this is actually part of AUD. But since I'm starting differentiation, I'm telling you the notations and everything. So now when I'll give you formulas, I'll give you y equal to x square, x cube, something, function of x. When you differentiate, you'll write ddx on both the sides. And here you'll apply the formula, whatever formula we give. Clear? And every formula that we have has been derived from limit. Since you don't need limit in 12, I won't teach you the derivation of those formulas. Directly we'll go to the formulas. Clear? So wherever you have written ddx, that means you're going to differentiate whatever comes after that. Clear? Online clear?
Yes, ma'am.
कोई दिक्कत?
नहीं मैम.
Okay. Yeah, that's it.